Welcome back, everyone. Today we're going to be looking at how we can solve some systems of equations in two variables, including nonlinear or quadratic functions. So the first system we're going to look at is a system with one linear equation and one quadratic equation. So graphically, what that looks like is you have a parabola for the quadratic function, and then you have a line for the linear function. And usually they will intersect at 2 points like this. So that's when you have two solutions. But sometimes you may also have a case where the line is actually a tangent of the parabola. So what that looks like would be something like this. So that's my parabola, and then my line is a tangent to the parabola. So in that case, you only have one solution. And the final case would be the unfortunate case where the line completely misses the parabola. So the parabola is like this, and the line goes like this, so they never intersect. So if this sounds familiar to our quadratic equation problem where we had three cases and we could find them using the discriminant, that's because this system of a linear equation and a quadratic equation can always be described as a single quadratic system. So for example, if you have y is equal to ax, y is equal to mx plus b, or I can, in this case, I'll use mx plus d. And then you have another equation, y is equal to ax squared plus bx plus c. Then you can always say ax squared plus bx plus c is equal to mx plus d when you're trying to find their points of intersection. So they're equal, so you can set the functions equal to each other. And then you can rewrite that as ax squared plus b minus m times x plus c minus d is equal to 0. So then the discriminant of this function, of this quadratic equation, actually gives us the number of solutions this system has. So that then we can simply apply the discriminant condition and we can find the value of this discriminant, and that should tell us how many solutions this system must have. So that's the method right here. You substitute the linear equation to the quadratic. If you have y is equal to x plus 1 and y is equal to x squared minus 3, you substitute x plus 1 for y, and then you get the equivalent quadratic equation. And you can use the discriminant to find how many solutions there is and what value of k gives exactly one solution. So that's a common question they'll ask where maybe instead of giving you this 1, they'll set it equal to k. Or maybe instead of giving you this 4, they'll say equal to k. So they'll give you one less number. So they'll just replace one of the numbers with k, and then they'll say what value of k gives exactly one solution. And in that case, the discriminant is gonna be 0. So you can go ahead and find the discriminant, first find the quadratic equation, the equivalent quadratic equation, and then you can find the discriminant, and you can. So if you have k and you have x, then you can go ahead and say -1 squared minus 4 times 1 times k is equal to 0. And then that gives you the right value of k for which there's only one solution. Sometimes they might also set the slope equal to k. So they might say y is equal to kx plus 1 and y is equal to x squared minus 3. And they want you to find the slope for which this line actually is tangent to this quadratic to this parabola or the graph of this quadratic function. So again, same method, find the equivalent quadratic equation and find the discriminant and set that equal to 0. We can do a practice question over here. Say x is equal to 49 and y is equal to square root of x plus 9. The graph intersect at point x comma y. So visually, x is equal to 49 is simply the straight line, x is equal to 49, and y is equal to square root of x plus 9. So y is equal to square root of x. That x that graph actually looks something like this. That looks something like this. Y is equal to square root of x. But since we have a plus 9, we know using the rules of function transformation that this, instead of starting at the origin, it's going to start at 9. We're shifting it up. So then this function looks something like this. So that's what it looks like visually. And now we want to find the intersection point. The algebra is very simple. X is equal to 49. You can just substitute that. That gives you y is equal to 49, square root of 49 plus 9. So 7 plus 9, or 16. The golden rule for always solving no- um, systems of equations with at least one or more nonlinear equation is substituting the linear into the quadratic or the nonlinear equation. So, for example, in the quadratic case, you substitute the linear into the quadratic. If you have a radical equation, like in this practice question, again, you substitute the linear equation into the radical equation. And then if you if you need to if you need to manipulate it, and you have to always try to manipulate it and get it in the form of a polynomial, usually a quadratic. So in this case, this question, for example, the practice question was really simple, but sometimes you might have a harder situation. If, for example, you had square root of x plus x, and then you had or square root of x plus 9 is equal to y, and then another one was y is equal to 2x, then suddenly this is harder, right? So if you had, for example, y is equal to square root of x plus 9, but the other equation, instead of x is equal to 49, you have x is equal to 2x plus 49. Then suddenly this equation is harder to solve, but once again, you want to substitute the linear equation, and then you want to go ahead and solve the quadratic equation, the resulted quadratic equation that you get by by isolating the radical and multiplying both and like squaring both sides and so on. So you always want to substitute the linear equation into the nonlinear equation, and you want to then manipulate it to get a polynomial and solve the polynomial. If it's a quadratic, you can use a discriminant to predict the number of solutions. And if you need to find a condition for one of the constants, that gives you exactly one solution. You just want to find that equivalent quadratic equation, and you want to set the discriminant to 0. As always, keep practicing, keep improving, and I'll see you in the next video.